What is regression models? So, regression models are fundamental tools in statistics and machine learning, enabling the analysis of relationship between variables and predicting outcomes. So, yeah, so it has some principles, types, applications taken into considerations of regression models. So we will be talking in deep. So as I mentioned, statistical method to examine the relationship between the dependent and the independent variable. The primary goal is to model the relationship and use to make the prediction or infer the trends. So they are like dependent variables, that is called the target, the variable which is being predicted or explained, and then is independent variable uh, predictors. These variables are used to predict or explain the target variables. So regression methods are foundation for both descriptive and predictive analytics. By analyzing the influence of independent variables or the dependent variables, regression aids in decision making and strategy formula. So, so then is the type of the regression models. So regression model can be broadly categorized based on the nature of the dependent variable, relationship between the variables, and the complexity of the models. We start with the linear regression. So linear regression models assume a linear relationship between the dependent variable and one or more independent variables. So in simple linear regression, there is formula, for example, predicting house prices based on their size, and they have certain assumptions, like linear relationship, normal distribution of residuals, or so. Then is multiple linear regression, which is let's take an example like predicting sales based on advertising budget across multiple channels. So there are certain applications like market trend analysis, risk assessment, or forecasting. And if we talk about logistic regression, it is used for binary classifications problems where the output is categorical, for example, 0 or 1. So applications like fraud detection, disease diagnosis. So the key feature of logistic regression is it provides probabilities which is suitable for the dichotomous outcomes or interpretable coefficients. And then is polynomial regressions, which extends linear regression by introducing polynomial terms of independent variables to capture non-linear relationships. So the example like modeling the growth curve of a business, but it has some challenges which is prone to overfitting the higher order polynomials. And then is ridge regressions. Uh, so that is a regularization technique for linear regression to prevent overfitting by penalizing large coefficients. So use case can be a high dimensional data set by multi-collinearity. However, it has strength. It improves generalization and reduces the variance. And if we talk about lasso regression, this is another regularization technique that performs uh, feature selection by penalizing the absolute value of coefficients. So use case can be like sparse data set where features are irrelevant. However, it has key advantage like simultaneous feature selection and regularization. And if we talk about elastic net regression, so it combines the rich and lasso for better flexibility. So use case can be a large data set with correlated features. And the expression applications can be a gene expression data analysis or finance. And moving forward, stepwise regression, an iterative method for selecting independent variables by either adding or removing predictors based on specific criteria like p-values, AIC. So, as example, like identifying key drivers for customer churn. And if we talk about strengths, simplifies model building, enhances relevance of predictors, and then is robust regression, which is designed to handle outliers and violations of assumptions in the data. And if we talk about the use case, the financial data set with extreme values. And the features can be resistant to outliers used for skewed distribution. And then quantile regression, which is focused on estimating conditional quantiles to the response of variable, not just the mean. And if we talk about the use case, it analyzes the impact of predictors on different segments of the population, and the application can be wage distribution analysis or the risk modeling. And in the last, nonlinear regression, so the model relationship that cannot be presented by a straight line. So example can be a growth models, dose response curves, and if we talk about the features, captures complex patterns or the interactions. And if we talk about assumption in regression analysis, for regression models to provide reliable results, certain assumptions must hold. For example, first one is linearity. So it's the relationship between the predictors and the target variables is linear. Then is independence. Observations are independent of each other. Then homoscedasticity, TCT, which is a constant variance of errors across all levels of independent variables. Then is normality. So errors are normally distributed. Then no multi collinearity. So predictors are not highly correlated with each other. So violation of these assumptions can impact the reliability and the interpretability interpretability of the regression model. Diagnostic tests and the transformation are commonly used to address such issues. And if we talk about evaluation of regression models, so assessing the performance of regression models involve various metrics. First one is mean absolute error, MAE. So it's an average absolute difference between the actual and the predicted values. Then is mean squared error, MSE. It's an average square difference between the actual and the predicted values. Then is root mean squared error, RMSE, which is square root of MSE. Then R squared, that is proportion of the variance in the dependent variable explained by the model. And in the last, adjusted R square, which adjust for the number of predictors in the model. So evaluation metrics are selected based on specific problem and the nature of the data. And then moving forward to the application of regression models. Uh, if we start with the healthcare, it predicts patient outcomes based on clinical data, analyzing impact of treatment on recovery rates. And if we talk about finance, it can forecast stock prices, economic indicators, risk assessment, credit scoring. And if we talk about marketing, so predicting customer lifetime value, evaluating the impact of advertising campaigns. And in engineering, it can model the relationship between the input and the output variables in the system design, and predicting the equipment failures. And in the last is environmental science, which can estimate the pollution levels based on meteorological factors. So it can model the climate change impacts. So regression models are applied across industries to optimize the process, forecast trends, and inform strategies. And moving forward, what are the challenges in the regression models? So, one is overfitting. The model performs well on training data, but poorly on unseen data. And then is underfitting, which is model fails to capture underlying trends in the data. And then is multi-collinearity, which is a high correlation between the predictors leads to unreliable coefficients. Then is outliers, in that extreme values can distort the model accuracy. And in the last, imbalanced data, which is unequal representation of classes and classification problems that affects the performance. So understanding and addressing these challenges is a critical for building robust regression models. And if we talk about advanced topics, uh, first one is uh, regularization technique. So methods like ridge, lasso regressions to prevent the overfitting by introducing penalties. Then is feature engineering, which is creating, selecting, transforming features to improve the model accuracy. Then is cross validation, which is techniques to evaluate model performance by splitting data into training and testing sets. And in the last, automated regression tools like AutoML and libraries like scikit-learn, TensorFlow, streamline regression modeling. And if we talk about future trends, so explainable AI, which is making regression models more interpretable. Then is integration with deep learning, which is hybrid models combining regression with neural works. And in real time application, implementing regression in IoT and real time decision systems. And in the last, scalability, which is enhancing algorithms to handle big data efficient. So future advancement will continue to expand the applicability and the efficiency of the regression models. And in the conclusion, regression models are indispensable for understanding relationship between the variables and making predictions across domains. Mastering their concepts, assumptions, applications equips practitioner to extract actionable insights and drive data informed decisions. Thank you.